Welcome to Mathematica for Biologists, Chapter 1, Part 3. So here we're going to start getting into looking at more complicated aspects of the data structure towards being able to do some statistics. First we'll start with doing means and standard deviations among the replicates. So just to remind you, we're starting out with our setting directory pointing to where the data file is. The data file we're opening is this time underscore speed.txt. See the URL in the description to download the files. I just wrote a reminder to myself what the data structure is: 9 columns, 100 rows each. It's speed versus time for these swimming frogs, and the 3 columns are 3 replicates: animals 1, trials 1, 2, and 3 for animal 1, columns 4, 5, and 6 for animal 2, and so on and so forth. So I'll show you a shorthand way of keeping track of the data. So for example, say we want to plot all of the animals, all of the trials of animal 2. We know that's columns 4 through 6. So again, our data is already defined as this spreadsheet of 9 columns with 100 rows each. So we can do column 4, column 5, column 6. This is just review from the last tutorial. So animal 2. So we're just making a list of columns, and then we'll list line plot that. And there it is. But it gets cumbersome to write everything out like this. And if there was many columns, we might get lost in the data. So I'm going to show you some shorthands to do that, and we'll eventually need those shorthands because we're going to make more complicated commands to search through the data and calculate means. So I'm going to make a slicing command here, or a slicing list to more elegantly slice things out. So you may or may not know, if we want to get 1 column, you just do that. But if we want to get 3 columns, columns 1 through 3, use semicolons. Column 1 through 3. Double semicolon will get you 3 columns. So that plots all of the information from animal 1, and animal 2 is 4 through 6. Animal 3 is 7 through 9. So that's cool. That shortens things a little bit, but we can even shorten further by just making a list of slice commands. So I'll just call that A for animal equals a list of 1 through 3, 4 through 6, 7 through 9. And it's not meaningful in and of itself, but if we use it within the data command, so we just replace, we have our double square brackets. It's easy to get lost in the brackets. We can put A animal 1, for example, and it looks a little overwhelming, so I'm going to break down that step into smaller steps just so you see what's going on. So we're going to develop a slice equals, and let's say that slice we want animal 2. Animal, so A2. That's going to give us the slice for animal 2, and that's 4 through 6. So that's cool. And so so instead of writing 4 through 6 here, we just use our slice. And that gives us our data. So we list line plot that. And it should be, so if we use the third animal, it's the same as above with our more brute force method. So that's really nice. That's going to shorten things. So now what we need to do is use our now new tools for slicing to make a table. And that table is going to be used to gather our mean data. And just in case you don't know how to use the table command is the most important command in Mathematica, in my opinion, and you should practice it on your own, but in case you don't understand how to use it, there's a table command, and there's always some iterator. You can call it whatever you want. I'll call it I. So the first argument is to do something, and then the second argument is to tell I to iterate over something. So I goes from 1 to 3. And so we should get a list. The output to a table is always a list. So we go from 1 to 3. So I times 2, 2, 4, 6, or whatever. You can see how that works. You can also do several things. You can spread this table out over multiple lines and define variables within this. So something equals I times 2, something else equals square root of something. So we can do multiple things. Importantly, if you're doing a table over multiple lines and you're defining variables within the table, you have to have a semicolon after each line, except for the last line. And we'll go over that later. That'll become clear later. So if we do this, so we're making a list of things. And we can also have two iterators. That'll give us a list within lists. So maybe say J is 1 through 4. And so that's going to get a little more complicated. We can add J, for example. We'll get a list of lists iterating. For every I, you get 4 J's, for example. Okay, so that's the table command in a nutshell. We're going to use that to go through at every time point in this data. Remember, these 3 replicates are supposed to be the same because of the replicate trials, but there's, of course, variability. The first replicate swam at a lower speed, the second one is slightly higher, and the third one is slightly higher. So we want to average all of these, average at each time point. So, for example, data, that's the first column of data, for example, at the first time point, and let's call it time point equals 1. And then, so we can make a list of this, and this gets tedious really fast. By the way, if you don't like selecting things, you can just select the head and click it 2 or 3 times. I forgot whether it's 2 or 3 times. Okay. So that is our data point for at time point 1, the first time point for the first column, second column, and third column. And there's a list of those. And if we take the mean of that, that's the mean for that time point. And you can see how this would get super tedious really fast. So we're going to make a table to do this. So now we're going to set up our table command. So I'll call this mean data equals table. And I'll set up our iterators. I'm going to have 2 iterators. Iterator 1 and iterator 2. And I don't know everything yet. I haven't figured out everything yet. So, but I know both iterators start at 1. We don't know what they go to yet. And this is going to extend over multiple lines. So just for a second, remember the goal for every single element in this table, what we need to do. This table is kind of like a loop. For every single loop iteration, what we need to do is basically get this data here. So we need data. We need to slice out the correct column as well as the correct time point. That's just kind of what we need as a reference. I'll put that in. quotes there, comment that out. So that's the goal. So what we need is information on what animal we're using. Animal. And that is, we'll call that iterator 2. And order matters here, and so you just have to use trial and error. We know we have 3 animals, so that goes from 1 to 3. And then we need a time point, because remember we're doing this for every time point, and that should equal iterator 1, I'm sorry. Okay, cool, and we know that we have 100 time points, remembering from our data structure, that goes from 1 to 100. I'll just comment here, 3 animals. And this is number of time points, so our rows in our spreadsheet. Okay, cool. So now we need to set up a slice based on what animal we're testing, and remember our slicing array looks like that. So we want to slice A using the double square brackets, and that's going to be our animal. That tells us what column to look at. But we also want to include the time point. So what we need is replicate data equals data, the slice, so that tells us which columns to take, and then we want to know which time point to take. If you have 2 arguments within the square bracket, it just goes down 1 more level in dimensionality. So this gives you the column or set of columns, and this gives you the row. So that's cool. This command here gives us exactly what we want here, or more specifically 3 values. It'll give us 3 values, a mean for each animal. So it's the mean of columns 1 through 3, the mean of columns 4 through 6, and the mean of columns 7 through 9. Okay, now all we need to do is use the mean command. And notice I put semicolons on every line except the last line. The last line is basically the data you want to go into the table. The semicolon just means don't put that data in the table, just use that to make calculations. Okay, I'm going to do my Shift-Enter. I ran it, and then here are all the data. We see a list within lists. You should see 3. The dimensionality should be 3 columns by 100 each. Just to check if it's not, we did something wrong. Okay, nice. 3 columns, 100 each. So that means 3, for each of the 3 animals, we've averaged those 3 trials. We've averaged the right 3 columns. So now I'm going to plot this list, line plot, mean data from animal 1. And if I plot all of the animal data together, each plot is the mean from each animal. So we can just verify that that mean looks correct. So I'll say mean, we're going to plot the mean along with the raw data. So line plot and make a list. So the first one is going to be data, I'll just do this by brute force, column 1, data, column 2, data, column 3, and then we'll put in our mean data, knowing that this is animal 1. And then I can't tell the difference what's going on here, so I'm going to use plot style. and I'll make all the raw data ones black, and the mean red and thick. And that makes sense. The mean is kind of right in the middle of all of them. Okay, this is great. What I'm going to do now is, that's part of the story, we need the mean and the standard deviation. Standard deviation is the same deal. We just, excuse me, copy paste this. Let me get rid of this. And let's just call this SD data. And super easy. Instead of using the mean command, we use the standard deviation command. Run it again. Now we have SD data. So now this is awesome. We're basically almost ready. So now we're going to plot we can do a list. So of course the standard deviation data in and of itself doesn't really mean that much. You could say SD data. And it just looks like that. But what I like to do to see the variability, I do the mean plus or minus the standard deviation for every time point. And so all you have to do is, for whatever animal you want, say, let's just say animal equals 2, for example. List line plot mean data for that animal plus the standard deviation data for that animal. And so that's the first plot that we want, and the second plot we want is mean data for that animal. And the third plot, as you can guess, is just this minus the standard deviation. And that's what that looks like. And for animal 2, that's for animal 1, this is for animal 1, and you can right away see the middle trace is the mean and plus or minus standard deviation. So actually, what this tells you right away is this animal is not very variable. If we look at animal 2, it's highly variable. So we see this huge standard deviation, and it's useful to do this at each time point because you can see at which time point it's most highly variable. And animal 3 is also highly variable. And now, let's use our tricks to manipulate the styling of the graph. So plot style equals the style that we define, style inflow. And we'll define our style info in a second. What I want to do is make some interactive little things I showed you in the last tutorial. And I have to remember how to do this. I think that's how you do it. And then I'm going to copy and paste that box setting. Copy and paste my little box. So now, okay, the style info that we're going to make, equals a list, one for each plots, and the plus standard deviation plot will be one list. The mean plot will be the second, and the minus standard deviation plot will be the third. So we'll do color in each of them. So I'll make the plus standard deviation maybe that's a nice color of blue. And I'll make that the same color for the minus standard deviation. And then for the mean, I'll make it like a really nice, solid blue color. And I'll also make the mean plot very thick. And then for these, I'll make it dashed. And so now our plot should look very pretty. And then semicolon that. So that's really nice. We can also do something. We can make this look much prettier, but I'll do that in the next tutorial.